In this video, we are going to be talking about samples, and our essential questions are: what is a population? What is a sample? What types of samples are biased? And what types of samples are unbiased? So what are populations and samples? Well, a population is the entire group we are interested in studying in statistics. So usually when we use statistics, we are studying some group or some large amount of things. So we are talking about the population when we talk about the entire group we're interested in studying. And then a sample is simply a part of the population. So I've got some examples here of populations and samples just to give you an idea of what we're talking about when we talk about populations and samples. So let's say I was interested in studying something about all the students at Spencer Middle School. That would be my population. If I'm trying to make an inference or a conclusion about all of the students in Spencer Middle School, that would be my population. Well, there's a lot of students in the school, so I wouldn't be able to particularly collect data from every single student in the school, so I might use what's called a sample. And my sample is just part of that population. So here's an example of a part of the population of the Spencer Middle School students, students in a math class. So that's a smaller part of the population. Even bigger than that, I might be interested in studying something about the people in Iowa. So if I wanted to know something about the people in Iowa, that would be my population. That is the entire group I'm interested in studying. And then obviously there are millions of people in Iowa, so it would be very difficult to collect data from every person in Iowa. So I might collect a sample of 5 random people from each county. That would be an example of a sample. And then finally, they don't have to be people. Sometimes we study things in statistics that aren't people. So let's say I wanted to know something about all the words in the English language, or I wanted to know, how often the letter G occurs in the English language. So that would be my population. That would be all the words in English. And obviously there are many, many words in the English language, so it'd be very difficult to study all those words. But I might take a sample of 100 random words from an English dictionary in order to collect data about my sample. So the take-home message that we want to get out of this video is that a sample can tell us a lot about a population without collecting data from the whole population. So we can tell a lot from a population just by taking a sample. So I like to make the analogy of a pizza. So think of this pizza right now as my population. This entire pizza is my population. Now let's say you're blindfolded, but you want to figure out what kind of pizza it is, because you can't see the entire pizza all at once, just like we can't see the entire population all at once. So would it be possible to tell what kind of pizza this is just by taking a sample? Well, the answer to that is yes. I don't need to eat the entire pizza to know what kind of pizza it is. Even though that might be fun, I'm not going to do that. So if I just take samples of this pizza, just to make sure it's not a half and half pizza or something, if I just take bits and parts of this pizza, I can get a pretty good idea of what kind of pizza it is. Okay, that's what we're talking about when we talk about samples. However, not all samples are good. We could have a bad sample. So if I just took a piece of the crust of the pizza, it would be very hard for me to tell what kind of pizza that was. That would be a bad sample. So to make sure that our samples are good, we need to know what needs to be good about them. So here are some things that good samples are. Good samples are representative of the larger population. Okay, they're not swayed one way or the other. Like the crust is not representative of the whole pizza. It's just one part of the pizza. So we need to make sure that we get samples from each part of our population, or at least every part of our population has a chance to be in our sample. They're selected at random or without preference. So that's what we mean by randomly selected. We aren't selecting something for a particular reason. It's just completely random. And the samples are large enough to provide accurate data. So if I just take one small piece of that crust, that's not a large enough sample in order for me to tell something about the whole population. Likewise, if I just picked off one olive from that pizza, it's not a large enough sample for me to tell what kind of pizza it is. So if I take enough large random samples, I can get a really good idea of what type of population I have. So here we have some kind of samples here. An unbiased sample is actually a good sample. So when we say a sample is good, we say it's unbiased. An unbiased sample is a sample that is representative of the larger population and selected at random. So if we take a good sample, we call that an unbiased sample. And then again, here we talk about random, and that's items that are selected without preference or every item has an equal chance of being selected. So when we select a sample, we always want to make sure that everybody in the population had a chance to be in the sample. Now, not everybody in the population can be in the sample because it's a sample, but everybody at least has to have a chance. And then lastly, we have something called a biased sample. Biased samples are bad. Biased is bad. A sample that is not representative of the population. So let's take a look at some good samples here. Here are some ways to collect some good samples from our populations. One of them is called a simple random sample. And a simple random sample is just when you randomly pick. It's just a random pick from your population. Everything has an equal chance to be selected. So an example here, 30 student ID numbers are randomly selected by a computer. So everybody has a chance, but they're randomly selected. Next, we have what's called a stratified random sample. Now, these can get a little bit confusing because they all start with S, but we have to make sure we keep them straight. A stratified random sample is when the population is divided into groups, and then we randomly select members of our sample from each group. So you're divided into groups, and then you randomly select from each group. And an example there was a population of election districts can be separated into urban, suburban, and rural strata. So they're just divided into those categories, and then samples are selected from the categories. And then lastly, we have what's called a systematic random sample. And this things are selected according to a specific time interval or according to a rule. So every 20 minutes, a customer is chosen. Okay, that's a regular systematic way to choose parts of your sample. So it's part of a system or it follows a rule. That's a systematic random sample. So all of these are random samples, but there are three different types of random samples. So let's go back to that pizza, and I'll illustrate how we can use each one of these methods with the pizza. So a simple random sample of a pizza would be just to select 10 random places on the pizza and take a bite. Okay, it's just simple as that. That's why it's called a simple random sample. We just simply pick random spots. Now, if we wanted to do a stratified random sample of our pizza, we're first going to divide the pizza into equal groups. So we cut it into 8 slices, and I'm going to select one random bite from each piece. That would be another way to get a sample, a random sample from our population. And then lastly, an example of a systematic random sample with our pizza is just to make a grid, and every 3 inches I'm going to take a sample. So I have a grid here where all these are 3 inches apart, and I just take a sample on that grid. So you can see that each one of these gives me a pretty good selection of the pizza, but they're all different ways to get a random sample. So those are 3 ways to get good samples: simple random, stratified random, and systematic random samples. So here are some bad ways to get data. These are biased samples. Biased is bad. One way to get a bad sample is to use what's called a convenience sample. And that's exactly what it sounds like. It's convenient or easy. It includes members of the population that are easily accessed. So I ask the first 10 students in the cafeteria line a question or a survey about food. Well, that is biased because those first 10 might all answer a question in a particular way that isn't representative of the whole population. So let's say I was asking these students what their favorite lunch is at school. Well, if they're the first 10 students in line, they might be pretty excited about what they're eating that day, so they might all be more likely to choose or say that they like the food that's served that day, and then your data is skewed or not reliable. So there's something special about those first 10, and not everybody had a chance to be selected. Another way to get a bad sample is called a voluntary response sample, and that involves only those people that want to or can participate in the sampling. So an example of that would be the principal sent an email to graduating seniors asking them where to hold commencement. Seniors are asked to vote through an online poll. So only people that choose to be a part of your sample are in it, and that introduces what we call bias, or it skews the results. So some more samples or examples of samples of bad samples. Convenient samples. I want to know what everyone's favorite lunch is in middle school, so I ask 10 people that I sit with at lunch. Now, this is a convenient sample because they're just who I sit by all the time and they're right there. I really don't have to put much effort into gathering that sample. Now, that might be biased because everybody I sit with are probably my friends and we all probably have similar likes and dislikes. So it might be skewed towards what our favorite food is and not really representative of everybody in the middle school. Another bad sample here is I want to know what the most popular restaurant is in Spencer. So I go to Sports Page and ask the first 25 people I see. That is terribly bad sample because all of those people that go to Sports Page are more likely to maybe say that Sports Page is their favorite restaurant in town because they're there. So that is a bad sample and not representative of everyone in Spencer. Voluntary response samples. I want to know if a hotel I will be staying at is good. So I check the online reviews. Now, online reviews are really a terrible way to collect a sample because these are voluntary response. Only people that want to respond are going to be the ones that respond and give reviews. Now, what type of person is going to be more likely to give a review? There's actually two types of people that are more likely to give an online review. People that really, really like the product and people that really, really hate it. So you're going to get those, or you're more likely to get those types of responses when you read an online review, whether it be at a hotel or other online reviews like Amazon. So our second example here, I want to know if the super glitter pony skateboard I want on Amazon is good. So I read the customer reviews. So again, the types of people you're going to get for your super glitter pony skateboard are people that really love it or really hate it. People that are just generally satisfied with it are much less likely to write an online review. So you're going to get what's called biased. You're going to get some favoritism or unfavoritism towards that product if you choose those types of samples. So we do not want those. So let's determine if these types of samples are biased or unbiased. So to determine the types of music at a concert hall's customers like best, all the people attending a country music concert are surveyed. And we're going to say that is biased. This is a convenient sample because everyone at the concert is already together. They are more likely to choose country music as their favorite type of music. So this is a very bad sample of the population of people that go to this concert hall. So no, this is a bad sample. We can't use that. Next, to determine which passengers' carry-on bags are to be inspected, every 8th person to check in will have his or her bags inspected. This is actually unbiased, so this is a good sample. And this is a systematic random sample because the items, the passengers, are selected according to a rule. So this is systematic because it follows a rule. Every 8th person is picked, regardless of who that is. Every 8th person gets picked, and that's how it's selected. So everybody in the population actually has a chance of being that 8th person, depending on when they line up, and it is totally random. Next, the student council wanted to give a survey to find out what students in the middle school thought about the new dress code. They selected 50 random student ID numbers from a list and gave those students a short survey. This is a good sample. This is a simple random sample because the items, the students, were selected from the population at random. So this is just simply a random sample because they just put all the student IDs together and randomly chose 50 of them to get their sample. Next, another middle school also wanted to give a survey to find out what their students thought of a new dress code. They put a stack of surveys in the library with a sign that said, "Tell us what you think of the new dress code," for 1 week, and then collected the surveys. This is actually a bad sample. This is biased. This is a voluntary response sample because the items, the people in the sample get to choose to be part of the sample. They were not chosen, they got to choose. So the people that choose to take the sample are more likely to have a strong opinion for or against the dress code. People that really don't have an opinion either way or are neutral, they're not going to be represented because only the people that feel strongly about it one way or the other are going to be self-selecting there. And then finally, the city of Spencer wanted to get input from people who live in the city about what kinds of new businesses they would like to see added to downtown. The city council divided the city map into groups, which are called wards, and selected 10 random homes from each ward to survey. So you can see that Spencer is divided into wards over here, and then they select 10 random homes from each ward. This is unbiased. This is called a stratified random sample because the population was divided into groups. the wards, and the people were selected at random from each group. So ways to get good samples and ways to get bad samples. So ways to get good samples were our three S's: the simple random sample, the stratified random sample, and the systematic random sample. Please make sure you write those down with examples because they get confused very frequently. And then there are bad ways to pick samples, and a couple of them that we discussed: the convenient sample and the voluntary response sample.